How do I stop this thing? All right. Sure screen. Back to this. Okay. I think we're on the. Nope. Okay, so we're at oxygen epoch and lactate threshold. Lactate production with exercise and its contribution as fuel. I want you to look on the last slide of chapter 4. It's going to go over it really easily. It's called the, oh my God, that's big. It's not called that, but you know, whatever you want to call it. Oh God, I can't go up. How do I? Cori cycle. Okay, I'll go over it really, really quickly, but I want to go over it more in the future. So exercise number 1, follow the path, right? It goes exercise. We turn glycogen into glucose. Glucose goes into pyruvic acid or pyruvate, then into lactate. It goes into our bloodstream. From lactate, it goes back into pyruvate and then back into glucose in our liver. It goes transferred over to our skeletal muscles again and rinse and repeat. And it just does this bottom portion. It does not do the upwards back into glycogen unless we're resting. Okay. Why would that make sense? Is because when we're resting, then we can make our glycogen, which is our big storage, right? So it's easier to store glycogen than it is to store a million. It's easier to store 20 glycogen than it is to store 100 glucose. So we only do that when we're resting because we don't need to break these down immediately. So we only do it when we're resting. Okay? That makes any sense or it doesn't make any sense. Let's see. Also, I've got to keep these videos to 10 minutes or else YouTube doesn't like it. So I'm trying to go through this fast, but also at the same speed that you guys need. Aerobic and anaerobic contributions relative to exercise duration. Pop quiz. Okay. If I am running to go through my crutch and it takes me, actually, scratch that. We're going to go through this like track. Track is easier. If I am going to do a 50-meter sprint, is it anaerobic or aerobic? It's going to be anaerobic. Why? I want you to imagine you can hold your breath. You can hold your breath for a 50-meter sprint. It's going to be really tough, right? But you can hold your breath for a 50-meter sprint. You don't need to take more air in. But for a 400-meter dash or one lap around the track, you're going to need to breathe. So what do you think that system is going to be? Aerobic or anaerobic? Sorry, aerobic. My bad. Because you're going to need to breathe to be able to continue going. If you don't breathe, you're not doing a lap around the track. You might be able to. You'd be a monster. I would respect that, but I can't do it. Okay. Let's see. Effect of exercise duration on carb, fat, and protein utilization as fuel. Our body at low intensity. This is a good slide. I think it's on the like up here. I'm trying to get through this fast. Come on, please. Good. This is a good slide. Slide 40. Okay. So change this to moderate intensity, by the way. The reason why is there's a typo on the next slide or on this slide. Okay. So I think of it this way. VO2 max, just think of it as your max. Okay. Just think of it as your max for right now. Okay. 20% of VO2 max, you're probably like jogging, walking, right? You're doing an easy thing. Okay. So prolonged exercise at low intensity, walking, it's going to burn more fat. Actually, it's going to burn all fat, 100% fat at a low intensity long term. It's going to burn fat. That's it. Super easy. The reason why this is important is we are burning a total of 3 calories per minute if we are doing a low intensity workout. We're burning 2 calories of fat per minute. Okay, this is general idea. Obviously, we're not trying to say like big people, small people, yada yada, more efficient, yada yada. Just think of it as general. Okay. For prolonged exercise at moderate intensity, 60%, right? We're going on a pretty decent jog. Maybe like trying to go for I'd imagine this as you're going to practice. You're doing this in practice and not at a competition. Okay. Competition, you're going all out, right? So practice, you're doing 60%. This is actually going to be the best fat burning zone. Why is it? Because we are now meeting in the middle to burn fat and carbohydrates. Okay. So we are burning fat and carbohydrates at this point. We'll go to the actually RER, which is the I don't know, rate of return or some shit like that. I don't remember. I think I'm thinking about finance. Anyways, um, we'll go over RER, which will kind of bring this out a little bit more. It's the ratios of things, but you are now using a lower percentage of fat as energy. You are now burning more carbs. This is usually the case when you start to intensify your workout. You're burning more carbs, which is kind of sad because I want to burn fat all the time. But you're burning a lot more energy because the intensity is higher. It's 9 calories per minute. So we're using more energy, which means technically we're burning more fat, even though we're using a less percentage of fat. So it takes 3 calories per minute that we're burning 3 calories per minute at a moderate intensity, even though we're using less fat at this case. Okay, so I'm gonna go actually through this slide. I got like 2 minutes left of this one, and maybe I'll cover rare in the other one. But where the fuck is the rare? Ah, okay, cool. All right. If anyone's super confused on this, it was hella confusing for me. Estimation of fuel utilization during exercise. Okay, fats. The ratio for all fats is 0.7 or 0.70. You'll see it on the next slide. The ratio for glucose is 100% or 1. Why is that? If you really want me to go technical, you see this number right here, 23 oxygen, they just put it right here. See this number C, 16. If you do the math, it's 0.70. Okay, there's carbon, there's 6 carbon, there's 6 oxygen. 6 divided by 6 is 1. That's the ratio. That's the utilization of fuel. That's the ratio, okay? So we'll go to the next slide. So for fats, we're using 100% of our fat, right? Only fat right now. The ratio is 0.7, okay? Because we're using fat. The ratio at 1.0, or utilizing 1, like we're getting a really good burn, is going to be only your carbohydrates at 1-to-1 ratio, a 1 ratio, your sugar, okay? Got 2 more minutes to explain. It's gonna be hard. So the only ones you need to know is 0.70 is fat. 1.0 is carbs or sugars. And 0.85 is when we're using 50% fat and 50% carbs. Okay, that's it. That's for those 2 zones. Okay, we're gonna go and try and cover fat max zone, and then we'll see if that works. So fat max. I don't know why it says moderate to intensity. Your fat max is it's when you're basically burning the most amount of fat. Guess what? That's most likely going to be in a moderate intensity for a long duration because you're using the most energy. Even though you're not burning as much fat per se, or 100% of your fat, you're burning like 33% of your fat. You're burning more because you're using more energy. That's your fat max. Okay, reach just before your lactate threshold. Lactate threshold and VO2 go up with practice, with exercise. So the longer you do this, the more adaptation you go to, your lactate threshold goes up and your VO2 max goes up as well. Okay, this is a good kind of chart for it on slide 42. Think of it as your fat burn is going up, right? You're using a ton of fat, and then you get to here and it starts to mix in the middle, 50-50. And that's your fat max. I don't know, somewhere in there is your fat max. I don't know. Cool. And we're going to pause this recording here so I can upload this one and not be destroyed.